So this one, I believe, was from way back in 2003 when you were all like just born, basically. Yeah, wow. Oh, man, that makes me feel old. Y'all were just born in 2003, huh? Oh, that's depressing already. Okay. So we got these two circles, x squared plus y squared equals 2, and x minus 1 squared plus y squared equals 1. Gives you some points of intersection, 1, 1, and 1, -1. And says R is that region that they've shaded. Set up an expression involving one or more integrals with respect to x that represents the area of R. So the integral that's going to give us that area, so that's going to be, if we're going to do it in terms of x, we're going to need to do from 0 to 1 of just this function here, because the upper region is bounded by the circle that is got the radius of 2 here, and our circle centered at whatever that is, the square root of 2. Or I guess it's centered at 1, 1, 0 with a radius of 1. So that's this one. So we're just going to integrate that one from 0 to 1. And we have to solve it for the positive version of y, because that's above the x-axis, which would be positive y values. So it'll just be the square root of 1 minus x minus 1 squared dx. And then the other little piece of it there is the integral from 1 to this point right here. Well, this point right here ought to be the square root of 2, because the radius of this circle is the square root of 2, and it's centered at the origin. So 1 to the square root of 2 of the other one, solved again for y. So just the square root of 2 minus x squared dx. Everybody good there with A? Hopefully. And if you didn't, yeah, so I was gonna say, if you didn't write out the integral for the first one, you could have just gone in and found the area of a quarter of a circle with a radius of 1 and said that's 1/4 pi, and you could have done pi over 4 plus this other, and that would have been good too. And that would have been fine. And that was worth 3 points. So 1 point for this, 1 point for this, or if you just said it was pi over 4 by using geometry. And then 1 point for having the correct limits. And it says you did lose a point if you forgot to put a plus sign between them. If you didn't like actually make an expression to say that it's going to happen. So yeah, that's that one. Good or no? All right, and then for part B, part B wants us to do the same thing except with respect to y. So we have to look at which function is to the right of every other function, to the right of the other function for all of the y values. So the circle centered at the origin is to the right of the circle centered at 1, 0. So we need to solve this x value minus this x value. So we need to solve each of those for x's. Since this is, since these are to the right of the y-axis, it's all positive x values. So when we take our square roots, they should always be positive, the principal square roots of them. So we'll solve this one first for x. And it's an integral from 0 to 1, because those intersect at a y value of 1. And so it should be 2 minus y squared. That's right, 2 minus, yeah, minus y squared dy inside of the square root for the first one, and then minus, should all be together, minus this one we need to solve for x, so that's 1 minus y squared, and then we square root that, and then we add 1 to that. So minus the, what did I just say? 1 minus y squared square rooted, and we add 1 to that. 1 plus 1 minus y squared square rooted dy. D1. There we go. Everybody good with that? Somebody's. The answer said it was. That it was what? One minus y squared. Is that? Let me look at the scoring, guys. Sorry. What does it say here? Oh wow, their scoring guide's weird. Oh, they have a minus. Oh, they have a minus there. If I plug in y equals 0, 1 minus 0, 2. Oh, that's weird. What is that? X minus 1 squared plus y squared equals 1. 1 minus y squared. Why does that become the minus? Oh. No. X minus 1 equals the square root of 1 minus y squared. Yeah, I mean, I guess, yeah, it should be a minus square root there, because if you try to plug in a, if you try to plug in a value for yeah, it should be a negative square root because the center of this, it goes around here. So this is the negative half of that square root rather than the positive half. The positive half of that square root is over here. The negative half of that square root is over here. And so we're looking at values that are in the negative half of that square root. So it should be x equals 1 minus the square root of 1 minus y squared. That's my fault. I would have, oh, how tragic. I would have lost a point there if this was the AP test. How sad and embarrassing. Does that make sense, though, why it's that, why it's the minus there? Wasn't thinking. Yeah, so, Molly, this is the positive half of that circle, and this is the negative half of that circle. And now I'm going to erase all the stuff I drew over that just so we can see it better. But this is the negative half of that circle, and this is the positive half of that circle. Right? To the right of the diameter that goes directly vertically through it is the positive half of the circle, and then to the left is the negative half. So when you square root, you get positive if you do it over here, and negative if you do it over here. And so since this part of our function is to the left of that, when you square root it, you need to get the negative square root instead of the positive square root. All right, any other questions there on B? Looks like they gave you 3 points for that, 1 for the right thing in the integral and 1 for the, or 2 for the right thing in the integral and 1 for the limits. All right, and then part C gives you the polar equations for them. They want you to use the polar equations to set up a formula to represent the area of that same region. So we've got r equals root 2, which is this one on the inside, and then we've got r equals 2 cosine theta for the other one. And so in order to figure that out, we can erase off of here again. So we should be looking at think about the intersection point there. The intersection point there should be at an angle of pi over 4. And so the first one, to get this chunk right here, we can do just an eighth of that entire circle. And then to get this other little piece here, so let's write out C, we can do 1/8 of pi times that root 2 squared. And then to get the piece of this other one, it should just be, I'll do this in a different color. This chunk right here should be this other circle from pi over 4 to where it comes in here at pi over 2. So an integral from pi over 4 to pi over 2 and a 1/2, and it should have our r value 2 cosine theta squared d theta. Or you could have written this first one as an integral also, but you could use the geometry. So I know it's pi over 2 because if I plug in, if this point is at pi over 4, right, then I know that pi over 2, when I plug pi over 2 into my 2 cosine theta, that's going to give me cosine of pi over 2, which is 0, which is going to give me an r value of 0, which is going to put me back in the pole. The part in blue, I said this is just a circle that's centered at the origin. So I know what its radius is, and if I'm going up to pi over 4, then that's just 1/8 of the circle. So it's 1/8 pi times the radius of that circle squared. No, Adrian, the red doesn't overlap with the blue. So the blue brings me straight in and just cuts off right here again, right? Oops. So that's this taken care of. But then as we look at the area, that's the bigger circle. We're looking at the area of this region. If this is pi over 4, where this other circle hits, and this is pi over 2, it's just giving me the area directly a straight line in from each of those points. So that's just from pi over 4 to pi over 2 in the blue, and that just brings that little tiny arc. What do you mean because it's not centered at x equals? Oh, okay, yeah. Okay, you're good, yeah. You're good, Adrian? Yeah, so it's not bringing the area into the center of the circle, it's bringing the area into the origin. Okay. Any other questions there on that one? And that one was 3 points. Correct limits on the integral was 1, an expression for the, and then each expression, one for the outer circle and one for the inner circle, for the larger and the smaller circles, one for each. Guess we didn't need that extra page. All right. Next one, we got x equals 5/3 y, and then x equals root 1 plus y squared, and S is the shaded region between the 2 and the x-axis, and they intersect at some point P. So for this one, we wanted to find the coordinates of P to start with, and then the value of dx dy for the curve. at that point. So to find the coordinates of point P, you just need to set your 5/3 of y equal to your √1 plus y squared, and then solve that. And that y is 5/3 y, it's not in the denominator. So square both sides, so you're going to get 25/9 y squared equals 1 plus y squared. And we'll subtract the y squared over there, which is going to give us 16/9 y squared equals 1. And y equals positive or negative 3/4. So we'll call that the positive 3/4 value. And then that gives us an x value. If we multiply that out by, gives us x equals 5/4. So 5/4, comma 3/4. Everybody good with the first part there, part A?
Yes.
Okay, and then to take the derivative of x with respect to y, okay, that's just a yes in the chat. So take the derivative of x with respect to y. This means we're going to take the derivative of √1 plus y squared. So that's 1/2 √1 plus y squared times the derivative of 1 plus y squared, which is 2y. 2's will cancel. And you got y over √1 plus y squared, which we will then evaluate at the y value of 3/4. So that's 3/4 over the square root of, I'm going to correct that as 16/16 plus 9/16. That's going to be 25/16. Square root of 25/16 is 5/4, which should give us 3/5. So that's 2 points for that and 1 point for that. Everybody good there with part A? I mean, yeah, they say you don't need to simplify, but I mean, this simplifies nicely. You should really, you should simplify. Every other math teacher is going to tell you to simplify. Just because the AP test doesn't want you to doesn't mean that you should be able to. All right, part B wants us to evaluate an integral expression with respect to y. That gives us the area of S, so that should be the rightmost function minus the leftmost function from 0 up to the y value that we had, which was 3/4. So for part B, we'll do an integral from 0 to 3/4. And it should be the right function, which was the root function minus the other one. So √1 plus y squared. What was it? Minus 5/3 y, I think. Is that right? I didn't write this was a calculator question. So you should have been able to use a calculator for that. But if you didn't, you should be able to do it without. So integral 0 to 3/4 of √1 plus y squared dy minus the integral from 0 to 3/4 of 5/3 y dy. And so this one, you would let y equal tangent theta. And so you'd end up with 1 plus tangent squared, which would be secant squared, which would be secant, and then the derivative would be secant squared. So that'd be an integral. And I'm just going to write y equals 0 to y equals 3/4 of secant cubed theta d theta, and then over here you'd have minus, that should be 5/6 y squared from 0 to 3/4. And then this should be the, what does that integral come out to be? Is it natural log absolute value secant theta plus tangent theta. Somebody remind me about this one. Is it plus 1/2 of that plus secant theta plus, no, I don't remember. We've done it so many times and I can't remember what it is. Anybody offhand remember what that integral is? Nobody? I don't really want to go through the integration by parts and do it.
I have it.
Oh, good.
It's negative natural log, the absolute value that you have, and then it's plus secant x tangent x over 2. Or, yeah.
Okay, they're multiplied together. Like that. Negative that in front with a 1/2 in front of the whole thing.
Yeah.
Okay. Cool. Thank you. I should be able to remember that, but that's okay. And then over here we got minus, what is that? 5/6 of 3/4 squared. So 5/6 times 9/16 minus 0. All right, and so we were using these are theta values. So tangent theta we know is y, and secant theta, if you draw the triangle, tangent theta is y. Then your secant theta just ends up being root y squared plus 1. So we end up with 1/2 negative natural log absolute value root y squared plus 1 plus y root y squared plus 1 from 0 to 3/4. And then this piece here, what cancels out of that? That becomes a 3 and that becomes a 2. So you got 15 minus 15 30-seconds. And if I plug in, oh, fun. Yeah, I don't know. It comes out to be whatever this comes out to be. I'm not going to go through and figure all that out. The natural log, the 0 is all just 0. So it's just this thing evaluated at 3/4. And now I'll just do the bad thing that I told Molly not to do, which was I'm not going to simplify this because I don't want to deal with that. 9/16 plus, well, it's 25/16. I should simplify it. Plus 3/4 plus 3/4 times square root of 25/16 is 5/4. So you get that, which they said comes out to be, now I have 0.346. This was a calculator question. Forgot to mention that. This was the only part you needed a calculator for, though, I believe. Any questions on that? I mean, conceptually, I think that's pretty straightforward. Set it up, and then you would just use your calculator to evaluate it. So, all right, part C. Okay, oh, we better hurry up now, otherwise we're not going to have time for this quiz. Okay, part C says curve C is part of the curve x squared minus y squared equals 1. Show that can be written as the polar equation r squared equals 1 over cosine squared minus sine squared. So that should be pretty straightforward. I mean, x is r cosine theta, so that's r squared cosine squared theta minus y, which is r squared sine squared theta, equals 1. And just factor out your r squared, and you got 1 over cosine squared minus sine squared. So that should be pretty straightforward. That was just worth, wow, they gave you 2 points for that. Yeah. And then part D said use the polar equation in part C to set up an integral with respect to the polar angle theta that represents the area of S. And so it should just be from 0 to whatever this angle is here. And this angle we should be able to figure out by just drawing a right triangle here, right? I mean, if this is our theta, we've gone up, what is that? X equals 5/3 y, so that's y equals 3/5 x. We've gone up 3 and over 5. And so, I mean, we haven't gone up 3 and over 5, but like that's the effective slope here. The slope is 3/5. And so the angle here, theta, should be the inverse tangent of 3/5. Really, we've gone up 3/5 and over 1, but that's fine. So we have an angle of inverse tangent of 3/5. So we're just going to integrate from 0 to the inverse tangent of 3/5, 1/2 of our function, or r squared. And so it should be 1/2 of the integral from 0 to the inverse tangent of 3/5 of r squared, which just was 1 over cosine squared theta minus sine squared theta d theta. Good or no? Any questions on that? All right, last one. This was a calculator question too. So, oops. Dang, I should have made sure to write those in there. Anyway, that's not a huge deal. I think you could have probably done all of this, but maybe part B really easily without a calculator. So we need to find this intersection point here, which you could have used a calculator to do. But 4x minus x cubed plus 1 needs to equal 3/4 x. If I multiply everything by 4, we're going to end up with a 16x, and we're going to subtract the 3x of 13x minus 4x cubed plus 4 equals 0. Which should come out to be, yeah, it doesn't come out real nicely. Okay. So you'd solve that, and you'd end up with, that happens when x is about 1.94045. Hopefully you all got annoyed that this didn't come out nicely and realized this was a calculator problem. So it just should be from 0 to 1.94045 of the upper function minus the lower function. And when you did that, you ended up getting about 4.514. Everybody good there with part A? Okay. I'm waiting as requested. Don't round until the very end. So they specifically say that in the AP stuff, that you shouldn't round until your final answer. Yeah, so always use all the decimals your calculator will give you until you get to the end of the problem. All right, part B, find the volume. If you take that and revolve it around the x-axis, that should just be pi times the outer radius squared minus the inner radius squared. So same limits of integration. Outer radius is the 4x minus x cubed plus 1 squared. Inner radius is the 3/4 x squared. And That one should have been super easy. 57.463. Any questions there on part B? All right, and then part C, it said you didn't need to evaluate it, but you're looking for the perimeter. So first off, this y-intercept here is 1, so there's 1 unit. And then the second part of it is this nice little linear piece here. Well, this is y equals 3/4 x. It goes over to, I don't know what the y coordinate of that was, but went over to x equals 1.494045, and they gave the y coordinate of that as 1.455. So, I mean, that's just a matter of taking 3/4 of that. And so it should be distance formula between the origin and that for that. So that'd just be 1.94045 squared plus 1.455 squared, all inside of the square root. I don't remember what those numbers were, but that's good enough for now. And then the last part of it should be an integral from 0 to that 1.9, whatever it was, value again, of the square root of 1 plus, and then the derivative of our function. So 4 minus 3x squared, just using the arc length formula. So that'd be what you'd do for part C. And it said you didn't need to evaluate, so that's good enough. That was worth 3 points. 1 if you use y prime, 1 for the arc length interval piece. So 1 for this, 1 for this, and then 1 for having the whole thing put together. You could have done the arc length formula for the other one if you wanted to. Yeah, that'd be fine also, Nick. All right, that was fun and exciting. That took longer than I was expecting. Any questions on that before we take the quiz?